In this video, we're going to be looking at asymptotes of graphs and how those are related to limits. And we're going to do so by starting with an example of the graph f of x is equal to 1 over x. So I'll just go ahead and draw that real quick. All right, well, this is our positive y-axis, positive x-axis. And what we'd like to look at or notice here is that f of x has a vertical asymptote at x equals 0. Since the function approaches infinity or negative infinity at x equals 0. Right? So we see here that we have this vertical asymptote, and as x approaches 0 from the left, our function goes off towards negative infinity, and as x approaches 0 from the right, the function y value tends towards positive infinity. And in fact, that's actually how we define a vertical asymptote here. So a line x equals a is a vertical asymptote of a graph of a function y equals f of x if either the limit as x approaches a from the left of f of x is equal to positive or negative infinity, or the limit as x approaches a from the right of f of x is equal to positive or negative infinity. And so that's our definition of a vertical asymptote, and notice that the function only needs to approach either positive or negative infinity from one of the directions, and then we will have a vertical asymptote at that x equals a value. Now, how do we actually solve this analytically, right? If we're looking at a graph, we can just tell from the picture what is going on here. But how do we determine analytically how to solve these? Well, notice what's actually happening here is we have something that is a constant divided by a value approaching 0. So we get 1 over something that approaches 0. That thing is positive if we approach 0 from the right. And so we get 1 over a very small but positive value. And so this goes off towards infinity. Then from the left, we get 1 over a very small value in size, but it is negative. So 1 over a very small negative, then this approaches negative infinity. And that's actually how we want to solve these problems analytically. So we're going to have two examples here to finish out this video. So with example 1, we are going to find the vertical asymptotes, or in this case just one, of y is equal to x plus 3 over x plus 2. Well, we can first notice that the issue occurs at x equals negative 2, right? A rational function is continuous everywhere, not in its domain. In its domain, is continuous everywhere in its domain. So the only issue we could have for a vertical asymptote, or the only potential place we could have for a vertical asymptote, is where our function does not, the x value that's not in the domain of this function. And that is, of course, x equals negative 2. So what can we do? Well, we can rewrite the equation. And we're going to do that by dividing here. So let's divide x plus 2 into x plus 3 and rewrite our equation. X goes into x one time here, so then 1 times x is x, 1 times 2 is 2. We subtract this off. All we're doing is long division here. And we should be left with 1. So this tells us that y is equal to x plus 3 over x plus 2 is really equal to 1 plus, and then we had a remainder 1 here, so 1 plus 1 over x plus 2. So let's just think about our function as this. So again, this makes it very obvious that our asymptote occurs at -2. And so let's actually decide analytically what our limits are. So to do this, the limit as x approaches -2 from the left of 1 over x plus 2. Really our function is 1 plus 1 over x plus 2, but this is going to go to either positive infinity or negative infinity. If this goes to either positive infinity or negative infinity, then this does the same thing. So I'm just looking at this part. So let's think about what's happening here. -2 from the left. If we approach -2 from the left, that means the values are like -2.001, -2.000001. But the main idea there is that those values are negative, and the absolute value of those is slightly bigger than 2. So something like -2.001 plus 2 gives us a really small negative value here. So we get 1, a constant, over something that is approaching 0 in the denominator, but from the negative side. So this goes towards -infinity. Limit as x approaches -2 from the right is very similar. Let's do that. Except now these are approaching -2 from the right, so that's values like -1.99. So -1.99 plus 2 gives us a very small but positive value here. So a constant, a positive constant, over values that are approaching 0 but are positive. We get positive over positive. So this goes to positive infinity. And so we showed that there is a vertical asymptote at x equals -2. We only needed one of these two to be true for there to be a vertical asymptote, but it was good to go through all of the problem here and all of the information. All right. We're going to continue on with one more similar example using trig functions. So example 2 is to find all vertical asymptotes of tangent of theta is equal to y. So first thing we notice is that y is equal to tangent of theta, which is sine of theta over cosine of theta. And we will only have issues here when the denominator is 0. Well, the denominator is 0, right? Cosine of theta is 0 when theta is equal to pi over 2 plus pi n for all integers n. Right? If we look at our unit circle here, cosine is 0 when we have pi over 2, 3 pi over 2, and any of these points. So any multiple of 2 pi of these 2 points, including negative multiples. So this would be -3 pi over 2 or -pi over 2. So another way to write that is just pi over 2 plus pi n for any values, integers in, right? We could add 1, n equals 1 here means 1 pi, so we get up to 3 pi over 2. If n is 2, we go up here to 5 pi over 2. If n is negative 1, we go back this way and we get to negative pi over 2. Negative 2 gives us negative 3 pi over 2, and so on. Okay, so now we need to determine what our limits do. So what is the limit as theta approaches, and this is actually going to break up into two slightly different problems. We're going to have pi over 2 plus pi n from the left of tangent of theta. Well, what does that equal to? Well, let's approach pi over 2 from the left. Pi over 2 from the left actually means smaller theta values. So if we're thinking about going around, that means we're approaching from this direction here. I know it looks like from the right on this picture, but by the left we mean smaller values than this. So if we approach from the left here, we notice that cosine is positive here, and sine is approaching positive 1. So the numerator is going to a positive 1, so a positive constant, and the denominator is approaching 0, but from the positive side, so you get positive over positive, and a constant, or something that's close to a constant of 1, over something that approaches 0, so that goes towards a positive infinity. If we think about any of the negative values, that's essentially the same thing, except we're approaching from here now. And we get that the sine value is a negative 1 up in the numerator, and the cosine, so the denominator, is small but negative values. So we get a negative over a negative, so again a positive. If we do the limit as theta approaches these values, but from the right side, approaching from the right is here and here on the picture, in which case we get positive 1 over something that is going to 0 but negative. So this is negative infinity. And over here we get negative 1, but then positive small values in the denominator. So we get a negative over a positive, which again goes to negative infinity. And this checks out with our graph of the tangent function. Pi over 2, negative pi over 2. Tangent function looks like this. As we approach these values from the left, so as we're approaching them from the left, our y value goes off towards positive infinity. As we approach from the right, we see that our function goes down towards negative infinity. All right. And that will end our video on vertical asymptotes.